What's going on, guys? Welcome back to another video here at Next Level Coding, and today we're going to be taking a look at try and except blocks within the Python programming language and how we can use them syntactically to more gracefully handle errors that might otherwise occur when we are writing out a Python script. If you guys find this video helpful, be sure to smash that like button and subscribe. But jumping right into it, to use try and except blocks in Python, typically what we're going to want to do is we are going to want to use all three, or at least two out of the three of the following keywords that you see on my screen right here when crafting any sort of function or class method. Now, the benefit of using try and except blocks, like I mentioned just a couple of seconds earlier, is that we can more gracefully handle and actually have more control of what happens within our script when inevitably an error does occur, especially as we construct more complex functions. Now, in order to use try and except blocks effectively, we're going to have to, as the name implies, create two blocks of code leading with the keywords try and except. We'll touch upon this finally keyword here towards the end of the video, but just think of that whatever we place within this finally block, it's always going to be executed regardless whether or not our script errors out or runs successfully as it is designed. Now, whenever learning something new within the Python programming language, I just find it is generally best just to go ahead and proceed with an example. So I created a very just simple function here, nothing crazy at all, whereby this function just simply adds two numbers together and returns the resulting sum. And I use the word product here because sum is actually a built-in function within Python. So just to go ahead and prevent any compilation issues, I went ahead and used the variable product. But essentially, if I go ahead and print out the results of this function, giving it two dummy numbers, you'll notice that indeed 2 plus 2 is 4, and we get the desired output, which is what we would expect. However, let's say somebody didn't know any better and decided to use a string instead of a integer. Well, if I went ahead and ran my program here, you'll notice that my program actually crashes, rather it errors out, and I get this idiosyncratic type error being raised here because Python thinks that I'm trying to concatenate this string with an integer, which is just an operation that is not allowed. Now, one option is to just let our program crash and burn and die. However, a more Pythonic way to handle errors like this is via a try and except block using the keywords we discussed earlier. Now, modifying this function ever so slightly, I'm going to go ahead and implement my try and except blocks, whereby I place all logic that should execute normally within the block that occurs first, which is the try. And you guys can think of this as the logic you place here in any try and except block is what should happen every single time your script is run when no errors are expected to be raised. However, we also want to be able to use this except block to be able to more gracefully, like I said, handle any error that occurs or notify us of the error that has occurred by using this exception as E syntax. And essentially what this does is Python will capture the exception that has occurred and assign it to this variable E here. Now, this variable could realistically be anything. Traditionally in the Python developer world, though, it is traditionally represented by an E, and we can actually print out the contents of this E, whereby we actually won't get the green text here to raise, but instead we'll get like just a regular string to be raised when we go ahead and run our script. Now, just for the sake of demonstration here, let's go ahead and just run our happy scenario once again, whereby it is a valid integer. If I go ahead and run my script, we do indeed get the 4 like we did before. But now if we go ahead and place a string within our function, you'll notice that when we go ahead and run our program, things look a little bit different here. We don't have that ugly green syntax, or depending upon the IDE you use, it might even be red text lettering here indicating our program crashed. Rather, we accounted for the fact that sometimes an error can occur and simply prints out the contents of that error message. And in this case, the error message is that we can only concatenate strings to strings, not integers. And so hopefully you guys can see by catching this error here, this can really help us speed up the debugging process by allowing us to print out exactly what occurred, or rather what went wrong when we tried running this script right here. In addition to just accepting the exception, we can actually go ahead and even modify this script slightly to go ahead and either return a default value or raise a different type of error instead of just the error that normally would occur. Now, if you guys recall at the earlier part of the video, the default error to be raised under this circumstance is a type error. Well, I can actually modify that behavior slightly by using this raise keyword. And so similar to how the return keyword is the last thing we will provide to a function in a happy scenario. The raise keyword also will allow us to raise a specific type of error should something go wrong with our program. There's actually another type of error that can occur in Python called a value error, and I can actually go ahead and raise this instead. And so if I go ahead and remove this right here and just sort of let my terminal handle the error for me, you'll notice that, well, first the thing that happens is that this type error does happen, but during the handling of the above exception, I actually personally raise the value error myself if I wanted to sort of override the result of the type error that we experienced in the subsequent step. Now, the second thing that we could do actually here is return even a default value. And so if I went ahead and returned a, let's say just a 0 instead, and instead of just simply printing out the result of my function, let's say I assigned it to some kind of variable called result, and let's just go ahead and call this function and assign the result back to this variable. Well, if I printed out the result of this variable after the error has been raised, well, you should actually expect, instead of a 4 being printed out, or rather nothing being printed out, you actually can expect a 0 to be printed out here. And indeed, that is the case because I constructed the logic in such a way that anytime an error is actually raised within my function, instead of it just crashing, I can actually sort of proceed by returning a default value and having my program, if it is larger than just a dummy function, to carry on. Now, before we move on to discussing finally blocks, if you guys find this video helpful or useful or even interesting in the slightest and want to learn more about the Python programming language, I actually created an online course called Software Engineering in Python, where we actually discuss and go over try and accept blocks in much more detail and how to be able to use them in conjunction with unit tests to really get some cool functionality out of any sort of logic we place within functions. Currently, as of October 2024, the course consists of 3 different modules, one designed to get you up and running in the Python programming language, another to get you familiar with the Flask framework to apply your newly acquired Python knowledge, and lastly, I just released a data structures and algorithms unit that is designed to give you a taste of what you can expect when studying for tech interviews should you choose to go all in on pursuing a career in the software engineering industry. The course only costs $50. There's a 100% money back guarantee. It comes with lifetime access. I'm planning on releasing an additional module each quarter, so as a result, the value of your purchase will be worth more and more over time. If you guys have an issue with the price, feel free to reach out to us at the email I've linked down in the description below, as well as what's popping up on your screen right now. We would love to negotiate the price with you. We don't want that to be a barrier of entry at all. Again, I've linked my website down in the description below, but now let's get right back to the video. Now, the last thing we're going to talk about is this concept of finally blocks. And as I mentioned earlier in the introduction of this video, finally blocks actually occur regardless of if an error is raised or not. And this is actually most useful whenever we are interacting with any type of database. One of the cardinal sins of software development is leaving a connection exposed, or rather forgetting to close a connection after we attempt to execute a query. And so one way to easily remedy that situation is by providing the closing of a database connection syntax to the function that is used to query that database. Now, because that's a little bit beyond the scope of this video and a little bit more of an advanced skill level, all I've done here is that within this finally block, every single time this function runs, whether or not it completes successfully or has an error being raised, I'm simply just going to print out terminating database connection to illustrate to you guys that in both scenarios, whether or not an error is raised, this block here called finally is going to run regardless. And so just to go back to our happy case scenario, if I go ahead and switch my string back to an integer and I go ahead and run my function, you'll notice that indeed I do get the number 4 return, but in the happy path block, which is underneath the try keyword, I do get the product, or rather the sum of num1 and num2 being added together successfully. And as a result, I print out process completed normally, but you'll notice also that in addition to just simply returning the product, I'm actually able to execute this finally block as well, which is represented by this line here, right? Like I terminated, or rather I'm just sort of illustrating the fact that I could terminate a database connection within this finally block, even if it runs successfully. But let's say that our function again errors out, and let's just go ahead and modify this slightly to return our default value of 0. Well, even if the program errors out in this scenario, you'll notice that in addition to just the error message being returned to us and our expected default value, again, whatever logic is placed within this finally block is actually executed. And in this dummy scenario, our database connection would be terminated as well. Now, in conclusion, you guys, I know when I was learning Python for the first time, this concept of try and accept blocks was a bit intimidating to me. It just seemed extremely complicated, and I just had a general fear of trying to implement one myself. But after you guys have had enough practice, and after you've created hundreds or thousands of different functions across your career, you will truly come to appreciate the powerful nature and the flexibility that try and accept blocks affords you as a developer when trying to make your code as efficient and clean as possible. But again, that's going to do it for this video. I hope you guys enjoyed it. If you did, go ahead and consider subscribing to the channel. I've got new tutorials like this dropping every single week. Smash that like button to see if you found this video helpful in any way. I have my course, Software Engineering in Python, links down in the description below and pinned in the top comment. But thank you guys so much for watching, and I will catch you in the next one. Later.